we are going to look at some basics of how to use Desmos. So I have a top 10 basics to get you started on your road toward really becoming a Desmos pro on the graphing calculator. So here we go. The first thing is it's really, really important that you log in when you're using Desmos. You can just use any Google account to log in, and the reason you want to do that is because once you log in, you can go up here to where it says Untitled Graph. You can click on there and you can actually name your graph and save it. And this makes it so that every time you log in, you can get back to the work that you had been doing before. So I'm just going to name this tutorial, and I'll link this in the description so that you can get to this tutorial afterwards if you have any questions or you need to go back and look at things again. So the second thing after you've saved your work is that as you keep doing work, up in the corner here, there's going to be a little save button, and when that turns green, it means things are currently not saved on the screen. So it's good to push that save button every once in a while so that you can save your work and you don't lose anything. The next thing I want you to consider as you're working on Desmos is to use folders. Now, under this plus button, there are different options of what you can put in here. There's expressions, functions, graphs of equations, notes, meaning you can just write some notes about what's going on in that area of your equations. It keeps things organized very nice. Tables, folders, which is what I'd like to talk about right now, and then images. The thing is, if you add folders, it does this really nice thing where you can have a folder like I have right here. It says using folders, and you can open up that folder to see what's inside. Then you can turn the triangle again to close it, and it keeps things very organized with what you're building. Especially if you have a lot of equations or a lot of things going on, it's really good to keep them organized in folders. The other great thing about this is you can turn on and off all of the things that are in that folder at once. So that way, you don't have to individually click on all of the equations and lines to turn them off so that you can see what's happening on the screen. You can just turn off all of them at once. It's really, really useful. So here's an example of a note, number 3, keeping things organized with notes. For instance, I could put a line in here with another note that just says horizontal lines. And then all of the things after that are my horizontal lines. That way, as I'm going through, whenever I'm looking for things, I can get to those horizontal lines right away. Another little quick tip is that if you click on a line in here in the graphing area, notice what happened. It highlighted the equation that's over there. So whenever I click on one of these, it's going to highlight the equation. So that way I can find the equation and work on that equation very quickly and easily just by clicking on the graph. Another really great thing is if I close this folder, and let's say I'm looking at another folder and I'm doing something else, if I click on this green line, it highlights the folder that came from. And I can open that up and it highlights the green line that was in there. So especially if you have a lot of lines, a lot of equations, a lot of things going on in this Desmos file, then this makes it really nice to be able to find exactly what you're looking for. So that is using folders. Super important. Now, my fourth idea for you is points. When you want to graph points, you can turn them on like this. We have the point 1, 2 and the point 3, 1. Now that's pretty simple and pretty basic, but some nice things that you can do is just click on the label and it automatically labels this point. You can label that other point as well, but we can go a lot further than that. If you hold down on the colored button next to this, it gives you options. You can, of course, change the style of your point, make it a bubble or an X. You can change the color of your point and keep things organized in that way. That's nice. But this is the really cool part, drag. If you tap on the drag button, you can either have this so that you can drag that all over, and if you have the label on, then you can tell exactly where that coordinate is no matter where you put it. Notice that this other one I can't grab onto and drag. So if I hold down here and I click drag, let's look at these other options. I can click on just drag vertically or just drag horizontally. Let's go with vertical. When I go over here now, it's not going to let me go right and left, but it will be able to drag up and down. Notice the x coordinate stays at 3 the entire time. This can be really useful for finding specific points that you're looking for, especially in some sort of art project where you're trying to match the picture behind. Let's jump into number 5, equations. So there are many different types of equations that you can draw in Desmos. And Desmos is pretty smart with knowing what type of equation you're trying to show. For instance, your normal equation, y equals 3x plus 2, that graphs very nicely, and we can look at all the values that that goes through. But also, you could graph f of x in function notation equals 3x minus 2. And it equally knows exactly what you're trying to do. But even better, imagine you're doing a word problem and there are apples and bananas related in this situation and you want to use A and B as your letters. When you type that equation in, just like you would normally do, A equals 3B plus 1, it's going to automatically know that what you mean is that A is on the y-axis, the vertical axis, and B is on the horizontal axis. And it knows exactly what you're trying to do. That's really nice. If we jump into the next idea, now this is where we start to get a little bit more advanced, and this is using sliders. Notice that in this folder talking about sliders, I've written this equation y equals mx plus b, and there's no graph showing over here right now. The reason there's no graph is because it doesn't know the slope m or the y-intercept b to use when graphing. But it does say add sliders as an option. So let's see what happens if I push all and add sliders. Well, it shows m equals 1, but it gives me this slider. Look at that. So now I could change the slope of my line and see what happens as I change also the y-intercept. That's really interesting. So you can do a lot of great investigations with this. For instance, if I go back here and I have my other equations available, when I start to use these sliders, I could investigate, well, if I want this to be parallel, then I need to get the slope to exactly 3, so it's parallel to these other lines. But when I change the y-intercept, I'm going to have parallel lines the entire time, and you can even change the color of that. Maybe I'll change that to red so my 3 lines are all different colors, and then it's very easy to see what's going on. So that's how sliders work, and sliders are perhaps the most powerful part of using Desmos. You can do a lot of great investigations with sliders. Now, you'll notice things are starting to get a little bit wild over here on the left side, so I'm just going to close these folders and get everything back into my nice organized manner here. So, tip number 7 is tables. So as we open this up, you can always add a table by just going to the plus button and clicking on table. And what that'll do for you is you can type in x and y values and graph those points. Right now it's not showing, but if I click on the button here, it's going to show those labels, and we'll turn the equations off so that I'm only looking at these points. That's really neat. So let's say that I wanted to change this. Let's say that this 2, 7 is just a little bit too high, so I'm going to make it 2, 6. And notice how easy that was to change the values in the table. And if I go down here, I could put more points into this table if I'd like as well. An important thing about tables is that it's not going to be labeled x and y. It's x1 and y1. And if you make another table, it's going to be x2 and y2. And you have to sort of keep track of that because you're not using just the letters x and y. And especially when you start looking at this next tip, regressions, that's going to be very important. Now, if I want to change the color, it's similar to before. I can just change the color of those points to whichever color I would like. All right. Now, let's look at regressions. I'm going to leave this table open with my red dots, and I want to look at regressions. So I don't have anything currently in here because I want to specifically show you how to build a regression. So if I just hit enter, it's going to automatically put something into that same folder that I'm working with. So here's how you do a regression. Instead of writing y equals, I'm going to write y1, and it automatically knows that I mean y with a subscript of 1. I didn't have to do anything special for the subscript. But instead of equals, I'm going to use that squiggly tilde sign. And then I'm going to say the general type of equation that I think this looks like. Now, I think this looks like a quadratic equation, like a parabola. So I'm thinking ax squared plus bx plus c, that type of equation. So instead of ax squared, though, I'm going to put a x1, and then I'm going to say squared to the 2 power plus b x1 plus c. And you'll notice right away what this has done. It's trying to build a parabola equation. And the problem is I've already used a and b, haven't I? So right inside here, this can happen and things kind of feel like they've gone crazy and things are not working. But I'm not beholden to only letters like A, B, and C. I've also already used the letter M earlier in here. So let's use a letter D and make sure that we haven't used that yet. And let's use a letter like J and see that we haven't used that. Now that has worked out great because those are letters for parameters that I haven't used yet, and it automatically tells me the values for D, J, and C that will give me the quadratic of best fit. So this has done a nice regression line, the best that it could do to find a curve to model that data that I had before. And it even shows me the apex right here, that it's actually lower than the red line. Now another nice little bit more advanced idea that you can do is called a residual plot, and you can look here at how far away from each of your points you actually are with your model. And if we go down here, we can see the residual plot showing. So that is really, really nice. And recall, if you see a pattern in your residual plot, then that can help you to realize that maybe that was not the structure of the regression that you really wanted to use. So that's some interesting stuff. Now, if I turn those off and I close those up, we can look at tip number 9. Tip number 9 is pretty fun because it's really just adding images to your picture. So let's add an image of an airplane. I like that. Let's add an image of an airplane. So we'll go here plus image, and then I just want to go to an image of an airplane, and notice it's a .png extension on the image, and that helps because it makes the background transparent. Now, the important thing about doing this is that the center right here is currently 0, 0. And so I could change that manually by saying I want it to go over to 3, 0, or I want it to go up to 3, 5, or something like that. And that's pretty good. But if we use what we had learned before about sliders, I would rather pick some letters like maybe K, comma, L. And notice it says right under here, do you want some sliders? Yes, I do. Okay, so now I can move this around however I want using these letters K and L. Well, that's pretty neat. Now, the other thing is I can change the size by changing these numbers in width and height. But what most people would really like to do is change the size just by grabbing the corner, and we can make that a smaller looking airplane on our picture. We can kind of zoom back in. So that is pretty good. Now, here's what I'd like to consider. What if I had an airplane that started right there and it kind of went down and came in for a landing on the x-axis? I think that would be pretty neat. Now, with our sliders, the only thing that we could really do is kind of bring it over and bring it down a little and over, and that would be really tedious. So we want to find a way using equations to make this happen that's going to work a little bit better. So here's the idea. I can go into my slider and I can say, I want this slider to go maybe from 0 to 10. Okay? And then when I go away from that slider, I can just say, all right, let's start there at 0. So now it's going to start up at this height. And then for my other slider, okay, well, I'd rather that the height of where it is kind of depended on the x value, depended on its flight downward. So I'm going to get rid of that slider. And instead of having a slider there, I'm going to build an equation. What if I said I want L to equal whatever k is minus 2? Let's see what happens. So if I push play on this first slider, oh, my airplane is flying upward. Look at that. Well, that's pretty neat. Well, what if I made it negative k plus 2? Let's see what happens when we do that. Well, it's kind of going backwards. Oh, it is flying upwards, but it only goes up to the 2. Now also, this k value is going from 0 up to 10, and then it's going back down to 0 over and over again. That's not really what I want. So if I go in here to the animation properties, I can change this so that it only does that direction through once, and I can see what happens as that goes through. So let's reset this to 0, and I see it only go through once. Okay, so that's nice. But I don't think this is really what I want. I wanted it to start at 4, and I want it to go downward maybe all the way to 8. So all I'd have to do is think about the slope of the line that would follow, and maybe make this negative 0.5x plus 4. And now I have this going down and coming in for a landing. Okay, good. Now I want it to stop at 8, so I'll put it over here. And you can just start having fun with building your airplane simulation to do exactly what you want. So that's a really nice part of putting images in here. And you can put more than one image. For instance, what if I wanted a background image on this as well? And so I make a background, oh, here's a lake. Okay. And I can take this lake image and let's make it bigger, of course, because we want our airplane to be able to fly into this, and we'll put it behind the airplane so you can see the airplane flying. Ooh, this is fun. And I'll move it over a little bit. I want to move it up a little bit. Okay, and I think it's going to make a lot more sense if my airplane is now quite a bit larger to go along with this picture. So let's just click on the airplane, and we should be able to click here, make our airplane larger, and we'll just run the simulation of it flying down over that boat and landing in the water. And we've just built this in a matter of just a few minutes. That is really, really neat. Okay, so let's turn those off, and we're going to look at tip number 10. Now, this is also something that, I've already shown how this works, but y equals 3x plus 2 again. We'll draw that in, and you notice that it's automatically blue. Well, if I go over here, I can change this to any of these 6 different colors. Okay, 6 different colors to work with. Not too bad, but one of the main things you'll hear about Desmos is that it's pretty strange that there are only 6 colors. So, if you are interested in being able to add more colors to this, then you should check out my other video on adding more colors, because there's a pretty cool hack that you can do to change the colors. To add as whatever types of colors you'd really like in your graph or in your picture, there's a way to get that done. Now, my bonus tip or trick is I call segmentation. All this is notice that right now we have a line that goes on forever, and so far all of our lines have gone on forever. But what if I really just wanted to look at a line segment? There's a very easy way to do that. If I put in a line like y equals, let's do something simple like y equals 2x minus 5. But I only want to look at a little segment of this line, maybe from right here where the y value is 0 up to where the y value is 1. All I need to do is use curly brackets, and inside there I'm going to say I want y to be between 0 and 1. And check out what happened. It only graphed from 0 up to 1, that little line segment. So I did the y values just between 0 and 1. Another way that you can do this is with x values. I could say I want the x values to be between 3 and 4. And notice now I have a graph that only shows the x values from 3 to 4. And I have a little line segment drawn in for myself. So I hope that these basic tips and tricks of using Desmos are going to work great for you. And please let me know in the comments if you have questions or other ideas that you need to find out how to do.